we are going to be implementing the infamous invaders now. And the very first thing I want to do is drag my Space Invader model into my scene. So we've got that here. And as we've done with other things, we will place this invader model inside of an empty object so that we don't have to deal with default rotation values that come from Blender in this case. So I'm gonna go and create a new object called this invader, and move my model inside of this empty object. I'm also gonna locate it in 0 when it comes to coordinates, and that is my invader model. And I want my alien to be looking at the forward direction, and that is already happening. The alien is the same both ways of the parent object, because we'll be moving the parent object, and it's always easy to just be able to move it forward. Now let me talk about the movement of the alien and how we are going to implement the behavior of this creature in our game. So I'm going to bring up a node, and we will move our alien. So if we've got our alien here, it will have a horizontal movement within a certain range. So we're gonna call this range horizontal, range H. And so it will start and it will move all the way to the edge of that range. And we're actually going to make it start at the very beginning of the range. And when it reaches the end, it will move down on what we will call range vertical, range V. And when it completes that movement, it's going to go back horizontally and so forth, until eventually it is either killed by the player, or if it ends up touching the player, which is something that we'll implement later in the course, if it ends up hitting you, that will be game over. And also if the aliens reach the floor, that is also going to be game over. That is just like the real game, I suppose. So that is for the movement of the alien, and we will set different, in order to make this alien work, we will have what's called a state machine. And basically I'm going to define some states, and then we are going to act according to what our current state is. So the states that we will have, there is a state that's going to be called moving horizontally. We will have a state that is for when we are moving vertically, and we also going to have a state for when the alien is dead. So the alien can either be moving horizontally, it can be either moving vertically, or it can be dead. And when it is moving horizontally, let's say that there will be a direction, which could be 1 or -1, and that will indicate whether we are moving that way or whether we are moving that way. So we'll have a variable that will have that direction. And well, as we mentioned before, we're gonna need this range, and we will need to keep to save the initial position somehow, so that we can compare how far we are from that initial position. And we will need to save how much we have moved. So that is something that I'm gonna call accumulated movement. So all of these things will come into play when we have the code. Sorry, this is there's no S at the end here, it's just movement. So when you are moving vertically, we have the direction is always down, so we're not going to make use of that direction, but we do need the range as well. So we do need a vertical range, and we're also going to keep track of this accumulated movement, which will be calculated from an initial position. And as you're moving, you're going to be accumulating the movement, and when that movement is greater or equal than the range, it means that we need to go back to the other state. So from moving horizontally, we can transition into moving vertically. And from moving vertically, once we reach that limit, we can transition to moving horizontally. And from any of the two, we can always be killed by a bullet, so we can end up dead. And when the alien dies, what's gonna happen is that it's gonna fall to the ground, and we are gonna change the material of the alien so that it looks like a gray. It's like it ran out of power and it's like a piece of junk on the floor. So these are just some ideas on what we are going to be doing now in the code. So what I want to do now is go back to Unity and save this invader as a prefab. So I'm going to drag this into my prefabs folder. And I'm also going to create a new script, which all of our aliens or invaders will have. And so I'm going to go to scripts and create a new C# script. I'm going to call this enemy controller and open that in Visual Studio. Now let me just make sure that the script is here. Yeah, the script is here, so we should be all good. So we mentioned quite a few things in our notes. So we said that we needed a range, and we want to set these two things as public properties so that they can be easily set from the editor or from another class. So for that, this will be the movement range. We are going to have public float. Let's call this range horizontal, and we can give it a default value of, say, 14. You can always change that later. And we're also going to have that range vertical, which I will set as a 1 meter or 1 Unity unit. There are other things that I need to set as well. For example, the speed at which we are moving. The speed should also be somewhere here. And we can set that to, let's say, 1 for now. And if it's too slow, we can change it. If it's too fast, we can change it. People always ask me where I come from, how do you know the numbers? And the answer to that is you just try any number and then you adjust. And Sid Meier, a famous game developer who created the Civilization series, that's what he recommends, and he just multiplies the number by 10 or divides by 10 just to get a first idea, and then you don't have to increase it or decrease it in such big amounts. But you first want to know around what number it is, and then you can just tweak until it feels good. Okay, so now, what else we said that we needed? We are going to keep track of this direction, which could be either 1 or -1. So this is not going to be a public property. It will just be an integer, which we're going to call direction. And let's say that by default, we are moving on a positive direction so that all the aliens start moving in the same direction. And we, like we said, we want to keep track of the accumulated movement, so that we can use that to compare with the range or the vertical range. So this is the accumulated movement, and this will be a float, and it will start at 0 because we haven't moved yet. We said that we wanted to have different states, and there are different ways on how this can be implemented, but we can use a data type that is called enum, and it's used to create enumerations of things when you have a fixed set of options for something. So I'm going to create that in here, and I'm going to create, these are my available states, and that is going to be of type enum, and we create it like so. So we're going to call this state. We can call it however we want. We're just going to call it state, and then you use the curly brackets and you write all the options, the available options for this variable. So this can be either moving horizontally. That can be one of the states. We can have moving vertically, and we can have dead. So if we can now declare variables that are of type state, and those variables can have only these 3 values. These are the available states in that we will have, but now we actually need to create a variable to keep track of the current state. And for that, we can declare that like so. So we can declare a variable of type state, and that is an enum that we created here, and then that will be state.moving horizontally or state.moving vertically or state.dead. In our start method, we can set this initial state. And let's say that we want all of our enemies to start moving horizontally. So we can say that the current state is equal to state.moving horizontally. You could use other types. You could even use like strings or something like that. But I think that enum is a great solution here because it is by definition for when you need to have like a fixed number of options. All right, so we've got the current state, and our behavior in update will depend on our current state. And we know that if we are dead, nothing else is going to happen. So we are not going to run. Nothing happens if the enemy is dead. Then it's just a piece of junk on the ground. So if the current state is equal to dead, to state.dead, then we are just going to return. So nothing else will be executed here. If it's not dead, it means that we are moving. And if we are moving, we want to calculate the movement that we need to move. And from physics, you would know that that speed is distance divided by time, right? So that means that distance is equal to velocity or speed times time. Therefore, we can declare our movement like so. Movement would be equal to our speed, which is a public variable, times the time that has passed since this was called last time, which is time.delta time. That is the time between these update calls. So this gives us a movement, and now we just need to figure out whether we're moving up or whether we're moving down or horizontally. So we can now use an if statement to check for the corresponding state. So we can have if the current state is equal to state.moving horizontally, it means that we are moving horizontally. So are we moving horizontally? So the answer to that question is yes. Then we want to check whether we've reached the end of the range, Because if we've reached the end of the range, we need to transition to moving vertically. If we have not reached this point, we just need to move our object. So I'm gonna make that check here. I'm gonna say, has the accumulated movement reached this range horizontal? And so if yes, then move down or transition to moving down, vertically. And if not, then let's just move the invader horizontally. So that would be an else statement here. And accumulated movement needs to be updated. We haven't done anything with it. It starts at 0, but every time that we calculate this movement, we should add that movement to our accumulated movement. So that updates the accumulated movement. And that means accumulated movement plus equal movement, which is the same as saying accumulated movement equals accumulated movement plus movement. We're basically adding movement to our accumulated movement variable. So if that accumulated movement has reached the end of our range, we want to transition to moving down. So transition to moving vertically. And that means current state is now equal to state.moving vertically. What else do we want to do? We also want to change direction, or we can do that here so that next time that we move horizontally, we'll move the other direction. So that let's say the direction, reverse direction for horizontal movement. Direction will be equal to direction minus 1, so that if it's 1, it becomes minus 1, and if it's minus 1, it becomes 1. But that's the same as saying times minus 1. So we are reversing that direction. And also we want to start counting again the accumulated movement so that we can then check for the next range, so that when we reach the vertical range. So we want to set, we want to basically reset the reset accumulated movement. So accumulated movement will now be 0. So that is once we reach the edge, but what if we didn't reach the edge? That's the easy part. We just move forward. For that, we just do, there are different ways of how this can be done. We can just do transfer position, and then we can just add the amount. So we can add a new vector 3 that is going to go on, or we can do vector 3.forward, actually transform.forward, so that the alien moves forward times the movement and times the direction, so that can be one way or the other way. So this should actually make the aliens move all the way to the limit in horizontal direction, and nothing else will happen. So we can actually stop here and go to Unity and just make sure that things are working how they should. So this silly error here is just something that appears when I connect the tablet that I was using to make the notes before. So it's got nothing to do with what we're doing. So I'm gonna drag enemy controller to the invader guy here, and I'm gonna apply this to the prefab so that it changes the prefab as well. Let's press play and see what happens. So let's press play, and actually I don't want to maximize, so I want to see if this is working. So this should move 14 steps, and then it should stop. But we could have put something in the console to let us know how far it is. I feel like it's already gone quite far. Okay, so I think it is working fine. We haven't spotted anything. So let's continue. So now once we are moving vertically, that's the part that we need to add. So if the current state is moving horizontally, we already know what's happening, but what if it's moving vertically? And I'm just going to use an else statement because there are no more states. But you could also use it to make sure that if you had more states, you would need to check that, or you could use something like a conditional switch statement. But if statements are fine. So this is if we are moving vertically. And if we are dead, we wouldn't get this far. So this will work. And if we're moving vertically, the process is similar. So I can even go and copy this whole thing and put it here. But now I have to make some changes. First of all, if yes, then transition to moving horizontally. Let's update the comments as well. So we're now checking for vertical range. And the transition, once we reach that point, will be to horizontal movement. So let's write that down here. Moving horizontally. And there is no direction reversal because we are not moving up. We do want to reset the movement, the accumulated movement. And if we haven't reached the edge, we should be moving down in this case. So it will be, in this case, it doesn't matter where the transform is facing, we are moving down, as in literally down in the y coordinate. So we can just do vector 3.down, which is a vector that is 0, minus 1, 0. So it is moving down on y with a magnitude of 1. So we've got that, and we multiply that by our movement, but we don't multiply that by direction because we are not using our direction. So this should do, and just for testing purposes, let's make this shorter and this a little bit faster. So let's try again, see what this thing will do. So our alien is moving, and what we would expect is that it goes down 1 and then goes the other way. So let's wait and see if that happens. Oh wait, so for that change to work, we actually needed to make the change here, but it is working, as we can see. It is just not going. It's just that the numbers need to be entered in this part. All right, so let's see what happens next. See if that works. Yep. All right, so we've got the enemy movement in place, and if we now go and change and make it go a bit faster, like 2, and maybe not move as much, we can also duplicate this, Control D, have a few of these next to each other, because that's what that's what it's gonna be like once we create the whole formation. So let's just test this whole thing and bring them all up. And now we will do the maximization and play, press play, and there we go. So we've got something happening. We can shoot them, but nothing happens yet once we shoot them. But they seem to be working like Space Invaders should work. So we've got that happening, which is great. So now I have a challenge for you. So there's something I want to do with the gun, with the bullets. If we go to our player controller, we are shooting bullets. I want my bullets to have the following behavior. So for that, I'm gonna need you to create a new script, which will be called bullet controller. And in this new script, add these 2 things. First of all, if a bullet hits anything, any collider, for that we'll be using the trigger event. So I'm using my bullets were trigger bullets. Destroy the bullet. So if the bullet hits anything, destroy it. And if the bullet ends up too far away in the level, you can set your own limit. And I'll leave that open for you to see how you want to implement that. Destroy the bullet as well. So if you basically shoot a bullet and it's falling off the map and it's really far away, just make sure to destroy it. So pause the video now, have an attempt to solve this, and I hope that you can do it. And if not, that's perfectly fine. Then I will show you the solution. All right, welcome back. Let's solve this challenge. So we're gonna begin by creating that script. So in my scripts folder, I'm gonna go and create a new script, which I'm gonna call bullet controller. And I'm gonna open that. And I'm just gonna make sure that it shows here. Yep, it shows there. And we're gonna implement both parts of the challenge. So the first part of the challenge was to create a script, and was that if the bullet hits anything at all, destroy the bullet. And that should be pretty easy because we can use the onTriggerEnter method, which is part of Unity, of MonoDevelop, of Mono behavior. And so if we hit anything, but by that I really meant anything, we're gonna destroy the game object. So for that, just type destroy, and we're gonna destroy this game object. So now if I go to Unity and if I start shooting, but not on maximization like so, we should pay attention to what happens. Well, they don't seem to be destroyed. Let's see what could be. Well, they need to have the bullets. The bullets need to have, let's go prefabs. The bullets should have a collider. They do have a collider. And then the ground, does the ground have a collider? The ground does have a collider. So I wonder why that is not working. So let's try again. Oh yeah, so we didn't assign this to our bullet, so that was the problem. So if we go now to our prefab, we should have added that component to our prefab. So we can drag our script to that prefab, and there it is. And if I press play now, and I start shooting bullets, so what is happening now is that the gun itself has a collider. So we don't need the gun to have a collider, so we have to change that as well. So let's go to our VR camera, select our gun, and then in the guns inspector area, we're gonna remove the collider component here because we don't need that. Let's try one more time. So now we are shooting, and notice on this side that when I shoot, new bullets are created, but then they are destroyed as they hit the building. So we've got the first part of the challenge working. We just now need to do the second part of the challenge. And the second part of the challenge was that if they end up too far away, we'll destroy them. And for that, we are gonna need to keep their initial position. So I'm gonna create a private variable here, which is going to be a vector3, and I'm gonna call this initial position. And when the bullet starts, we're gonna set that position to the position of the bullet, so that we can always access that initial position. Now, how far away, that is the distance that we can define up in here, and I'll make it a public property. So this will be maximum distance. And let's say, well, this should be a data type of float. Let's say that if it goes further than 30 meters, 30 units, we're gonna remove them. So then we have a few options here. One option is to calculate the distance between the current position and the initial position, and see if that distance is greater than or equal than maximum distance. But calculating distance is a bit of a costly operation. So what we can do instead is just compare the difference on each coordinate. So I'm gonna calculate the difference in all coordinates, and if any of those is greater than 30, then we will destroy it. So as I said, there are different ways of doing this part, and the part that the road that I'm taking is just a little bit faster than calculating distance, because distance calculation can be easily done, but because it's doing a square root, it is more of a process. It requires more processing than just subtracting numbers. So if the initial position x, this will be the difference on x, we can calculate it like so, position x. So this is this number. We check that this number is greater than maximum distance. But this number can sometimes be negative, because you could have that this is a negative number and that this is not as a big of number. So we need here the absolute value. And for that, an easy way to do that would be to include system and just type here math.abs, so that this number is always positive. So that gives us our difference on x, and we can copy and paste and do the same thing for the other coordinates. So it will be y, and this will be it will be z, and z here, and y here as well. And now we just make sure that these are all less than 30. So we're gonna type destroy if it's too far away, and so we'll do if difference x is greater than equal than maximum distance, or the same thing for the other coordinates. So or this, or the same thing for z. So if any of those things are true, then we are going to destroy the bullet. And that is something that we can also easily test, because if I shoot to the sky, that will not enter in any collision, but eventually, so if we pay attention there, eventually it disappears. So there we go. We've got all of these things working, and that's it for this lesson, and I will see you on the next lesson.